Can you see my screen, right? Hello.
Yes.
Yeah,
Yes,
can you
Suresh,
see?
it's visible.
Yes, we.
Yeah, okay. So yesterday, what we said. Okay, so we already discussed, right? UPS and power supply, battery, host PC. So host PC usually what will have will be having the TA software. Okay, that is nothing but the test automation software. Okay, so that consists. I mean, usually for any hill system, there will be some softwares. It can be a GUI and can be created using any generic software like Canoi, Capel, or dspace or Protect TA. So these are the different type of hill automation systems. Okay, so usually, I mean, what we'll do in this test automation software, so we'll runs the all the test cases. Okay, so by on a single press on singular start button, so we can start the all the test cases at once. Okay, so that is the use of test automation software which will be in host PC. Okay, so there are two approaches in test automation software. What are they? One is writing a script for each test case. Okay, and by using a different scripts, it can be a VB or Python or the C sharp. Okay, so writing next one, second one is writing a test case in a predefined test format. Okay, so we have seen, right, already. I mean, for manual test cases, you will be writing, right? I mean, the test cases template will be there, right? Test format will be there, template or test format. So in that we need to write the test cases and execute. So there are two types of testing, writing a test cases. Okay, so one is a throw script and another one is a Excel sheet, which is a predefined test template. Okay, so next, TA architecture and a hill, right? So what we'll have in this test automation architecture and hill. So usually this we know already. Hill test bench. What are there? I mean, simulator, FIU, and everything. So everything will be there. And host PC, what will have? Test case sheet. That could be like a test case template, or I mean, written in a Excel sheet or in a Python script or any language. Okay, and there will be a like a analyzer parser. Okay, so our IO mapping. So IO mapping also we can do that. Okay, here analyzer, parser, and IO mapping. What it will do? So it will capture the data from the test cases and it will interpret, right? So in test case, what will give? Will give the information, so and so signal, so and so preconditions. So those data will be what it will do. It will analyze and then parser in the sense it will interpret. Okay, interpret and it will map, IO mapping, right? So if you are giving a particular signal name, right, vehicle speed something in the test case, so that will be mapped to the hardware of a hill automation, right? Hill automation system, right? So from there, how it will go to the ECU, right? CAN signal, vehicle speed CAN signal. How we are giving from the test case? If you are mentioning that CAN signal, that will go to the analyzer. So it will analyze. So what signal it is, then it will pass. Okay, it will interpret. So we are giving in the text in the Excel sheet. Okay, then it will interpret through the parser and then it will do the IO mapping. Okay, IO mapping in the sense, so for which signal it has to trigger. Okay, in DBC we'll have a signals, right? So those signals will be triggered by the hill automation and it will be straight go to the ECU. Okay, so that is the thing, IO mapping, and then IO manager. It will manage everything. So whatever the communication happens between the test automation and hill test bench, right? So that will be managed by this and a model interface. So we told, right? I mean, we already discussed plant model, MATLAB model. Okay, MATLAB Simulink model. That thing we can interface here, right? So through the model only we are triggering the signals to hill test bench. Understood? Here you can see the arrow. Okay, so from the model only we'll get the all the signals goes to the hill test bench hardware and from there it will goes to the ECU, and from ECU inputs will be there, right? So ECU inputs will be from model to ECU, and from ECU outputs or from ECU to simulator and then model interface, and like this test cases. So in test cases we can update those outputs also. Okay, what is the output value? Okay, whether it is expected or the, I mean, actual one, we'll compare, right? Expected and actual. Okay, so both will be compare, and then with respect to that, pass or fail will be decided. Okay, so this is the test automation architecture. Clear? So then this is a normal basic whatever we discussed yesterday and today, right? I mean this one. So this is a basic hill automation, how it works. Okay, then we'll goes to the dspace hill, right? So dspace hill, what we'll have? So usually, I mean, in Displace Hill, we'll have it's a typical hill test system. So most of the organizations are using the same DSpace, okay, hill automation. So which is a hill system comprises of the simulation hardware and the accompanying a software. Okay, connected to the system is the unit under test. Okay, so unit under test means, hello.
ECU which we are testing.
Yeah, yes, device under test or unit under test is the same. Okay, so what we are saying here, so it comprises all the simulation hardware accompanying the software as well, and next it will be connected to the device under test or unit under test. So which usually is one or more electronic control units, ECUs, right? Containing a new function or ECU software to be tested, right? The device ECU will be tested in the hill automation. Depending on the use cases, further real hardware components can be added to the test system. Like what are the systems you know? Airbag, steering, brake system, or any other ADAS or anything, we can test it in hill automation system, right? So this is how it looks like. So DSpace hill automation complete hardware. Okay, so it will be from the small size, medium size, and also the, I mean, large, for large complex projects we can use big size racks also. We'll call it as a racks. Actually, you can be seen, right? In our organizations, if we there will be a, like a server room. Okay, there are like a racks, right? Everything. I mean the complete LAN port, server related, and internet related ports will be there, right? So likewise, it will be a rack, and will be having the all the compartments, right? So what we discussed, so there will be a power supply, there will be a simulator, there will be a load box. So this is a BOB box, okay, and there will be a load box, okay. So likewise, everything, all components will be there here only, right? So this is how it looks, hill automation hardware. Okay, so this is a dspace simulator. So usually what we'll have here, remote control power supply. We know, right? Program control or remote control power supply. We discussed, right, yesterday.
Yes.
So it will be
Yes.
it will be useful for varying the voltage from minimum voltage to maximum voltage.
Maximum.
Okay. So remote control means, so we can operate through the softwares, right? So next, then what will have, modular hardware, processor board and IO board with the signal conditioning. Okay, so this is a simulator. So what will have, processor, I said, right? So there will be a Linux or QNX OS will be there, and there will, upon that there will be a RAM, ROM, and everything, all the components like CPU. It will be there. It will run everything, right? So also it will be having the IO boards and signal conditioning. Okay, so signal conditioning what? ADC, DAC, and digital IO, CAN, LIN, Ethernet protocols. So everything will be there in the signal conditioning. Okay, then next, ECU connector. Okay, so ECU connector, what it is? So to connect the ECU. Okay, so it will be there, right? ECU will be having the digital IOs, CAN signals, and ignition input, and battery voltage input. and also it has the outputs also. Okay, so those things can be connected over here, right here. And next, so this is a OBD2 connector. Okay, so usually for diagnostic communication we'll use this OBD2 connector. And next, failure insertion unit, I told, right? So to insert the failures, right, failure modes like short to battery, short to ground, those things we can do that. So and the external load cards and external connection of real-time loads, right? Load box I told, right? So those things also will be there, like high beam lights, okay, motors. So we can connect to this, right? So this is a typical, I mean, the hardware how it look like, okay. And next, so yesterday we discussed, right? So dspace internal, so this is a hardware and this is a internal how it looks like, right? And dspace with harness how it will be, right, real time. Okay, so these are the harness, all wirings and everything, so which will be connected to the hardware signal conditioning board and the ECU and everything. Okay, as we just discussed what it is, dspace hardware, processor board, IO boards, right? So this is a hardware will be having dspace processor and the whatever the OS will runs, right? So that it will have in here. And next, signal conditioning. Signal conditioning I told, right? I mean whatever the signal passing through to the ECU, ADC, DAC, and CAN are related. I mean PWM cards. So everything will be there in this box. And next, what we'll have? So loads and failure simulation. So we'll be having loads and also the failure simulation is FIU unit. Okay, FIU will be there here, and there will be a external connectors also for real loads. Okay, and next BOB, breakout box. Can you see here breakout box? So it will be like a switch, open and close, right? So and next, power supply. So power supply, this is a part of power supply and it's a programmable power supply. And next, power switch and ECU connectors. Okay, so it will be like a switch on the hill automation system, complete hardware, and also there will be some connectors, and there will be a like a VIO for the ECU also here. Okay, so this is a complete rack and how it looks like. Okay, and next, so how the communication happens from the host PC. Okay, host PC will run the test cases, right? So that communication happens through the PCI bus. Okay, so this is the processor simulator, and this communication happens PX20. So where is their PX20? This one is the PX20. Okay, so that will be communicated through the PCI bus. And next, FIU. I told that yesterday we discussed. We'll be having the LAN 1, LAN 2. Okay, LAN 1 will be for the processor, and LAN 2 will be for the FIU, right? And next, the Windows host PC connects to the dspace simulator using the PCI peripheral component interconnect card. Okay, and next, dspace software running on the host PC and uses this interface to configure and control the dspace simulator hardware and also to exchange data between the host PC and simulator. Right. So what we'll use? So we'll run the test cases. Whatever the data signals we need to send, we'll send it from here, and it will goes to here to the PCI bus, and we will get the output from the ECU to the same host PC. It's a to and fro. Exchange the data between the host PC and simulator. And the only exception to this interface is the fault insertion unit. Control of fault insertion unit done through the PC's serial port. Okay, so PC's serial port, we can do that. And next, so what is the PHS bus? Peripheral. What is PHS? So PHS bus is nothing but the communication between. I mean, the PCI bus is like peripheral component interconnect. Okay, so this will be like a communication. I mean, communication interface like between the host PC and simulator. But PHS bus is a physical layer. Okay, so likewise Ethernet or anything. So that is a like CAN protocol. There will be a physical layer, right? hardware, I mean the wire, coaxial wires and all those things. Okay, likewise here PSHS bus is a hardware, I mean sorry, communication interface between the IO cards. Okay, so what it will do, allowing access to up to 16 IO boards, which is a 32-bit IO boards. Okay, so what we said, there will be a like IO boards will be there, right? In if you see here, processor, there will be a IO boards. Okay, so from host PC to this one simulator PCA bus. Okay, so in this simulator there are IO boards and processor boards. Okay, so between this communication, we'll use the PHS bus. Okay, so allowing access to the 16 IO boards, which is a 32 IO bus. Okay, so there will be a 32 IO buses will be there to access the 16 IO boards. Okay, so for communication between the processor board and IO board, PHS bus. PHS bus provides a standard control lines for writing and IO error. The IO boards that support a IO error line can indicate the and react individually to the errors. Understood? It's like, I mean, it's like, I mean, in our desktop, right? So there will be a processor will be there, and there will be some cards also we can uh, plug in, right? So we can place like a VGA card or something like graphical display cards and RAM, ROM. Some cards will be there, right? So those are kind of even USB, Ethernet cards. So those things we can. I mean, those are the example for the, as like, I mean, IO boards. Clear?
Sir, I have
So
doubt.
yeah.
And sir, suppose thing, kindly go to the previous slide, please. Sir, suppose thing that we have to access remotely all these things, right? That FI and whatever the PX20 chassis.
Hmm.
So any network problem will happen. What we have to do? And supposing that testing is going on, we have to test it again from starting onwards or what? Two things I discussing to mind.
No, how, what is, I mean, a situation, how it will be off, I mean, is,
Supposing that remotely the link failure happened between source to destination. So what we have to troubleshoot all these
yeah,
things.
same thing. See, the test cases interruption happened, right? Whatever the, we need to check that. One thing, where are the test cases are interrupted, so that we need to go to the test case and whether it is not executed or not. From there, we can run the test cases. Or else, if you're interested, then we can run the test cases from the starting itself. That is
Okay,
our
okay.
wish.
Sir, supposing that any network issue will happen, we have to consult the network department or what?
Network issue? What network issue?
So from source to destination, any issue will happen.
No, no, no. So this is a not network. Why they will interfere? This is our system, right?
Okay, okay,
This is not connected to the internet.
okay. It will be locally accessible, right?
Yeah, yeah. Locally accessible. If you want to access remotely, then will be a, there will be a like a remote access portals will be there, right? A team viewer or something else.
Okay, okay, fine,
Okay. So using those
fine.
things.
Yeah, fine. Thank you.
Okay. So and
Yes.
in signal conditioning box, so what will have? There will be a like a boards. Different boards will be there. Okay, so like DS1006 is a processor board. So this is about the hardware I'm telling. And next 2003 is a multi-channel AD board, and DS4004 is the Hill Digital IO board. Okay, DS5376 is a wiring board. Okay, so to connect between the all the digital IOs, AD boards, and everything between processor and IO boards. Okay, and next, so there will be a programmable power supply, right? So what we said shall contain the power 10. So this is a part number. Okay, so this is a power 10 part number for this programmable power supply, and vehicle battery simulated remotely programmable power supply, right? So how much voltage will get? Up to 30 volts. Okay, so 0 to 30 volts we can vary, and one with the in output voltage of 60 volt, VBAT also. There will be a two outputs will have. One is a maximum 30 volts and one is a 60 volts VBAT. Depends on our requirement. We can use 30 volts or 60 volts. Okay. And next, breakout box. So we already know, right? A breakout box, what it will be? Available external connection to dspace simulator, or also for integration into the dspace simulator chassis if required. So access to all the signals available at the panel, right? So through this we can access all the signals, whether it could be a CAN signal, digital IO signals, or analog signals. Everything we can interact. I mean, whatever the ECU is getting, right, inputs and outputs, those we can get access here, right? And next, so dspace. So those are the about the hardware related, right? So coming to software tools. So software tools where we'll have in the host PC. Okay, so what are they? One is the configuration desk, second one is the control desk, third one is the automation desk, and next MATLAB model. Okay, so we already discussed, right? MATLAB model for what we'll use? For developing the plant model. Okay, so we'll discuss all the first three: configuration, control desk, and automation desk. How it will be, we'll going to see that. Okay, and next, configuration desk. So what it is? Okay, so configuration disk is an graphical configuration and implementation tool. So there will be a graphical user interface will be there in configuration disk, right? Ideal for handling the applications from small and large hardware in loop test based on dspace real-time hardware. Okay, so configuration disk is basically the dspace software. Okay, so what it will do, it will do the real time, it will test based on the dspace real time hardware, includes the implementation of behavior models and function code. Okay, so configuration test, what it will have? Behavior models and IO function code. What is behavior models? So the whatever the ECU we are going to test, right? So that is for what behavior? I mean, how it has to be. We have to simulate the inputs. Okay, so whether it could be a DVC or anything. So the complete functionality to test. So everything we can configure over here. Likewise, what we can do, we already discussed it. There will be a mapping box. Okay, so what it will do, it will map. So from the a host system to ECU. So what it will do, usually the host system is having the all the DBC and all the IOs, digital IOs, and everything, right? So those things will be configured in the configuration disk. Okay, so whether it could be a digital IOs, analog IOs, and CAN signals, LIN signals, Ethernet, and DBC file, CAN DBC file. So all the signals will be configured in the configuration disk. Got it? And next, configuration disk provides a clearly structured overview of all of the external devices configured in real-time hardware and connected behavior models. Clear. For example, if it is a PWM is there, right? PWM or some ADCC will be there. Resistive input will be there. So those things when we can do the calculations and we can map it to the actual hardware uh, input. Clear? And next, what it will do, configure real-time applications graphically and with an extensive automation API. Okay, and manage signal paths between external devices and behavior model interfaces also. So what it will do here, basically the name itself, configuration, right? So it will configure real-time applications graphically and with an extensive automation APIs. So APIs in the sense, so there will be some libraries will be there inside the configuration desk. So those things we can use it for automation. Okay, configuration and everything we can use it for. Okay, and next, manage signal paths between external devices and behavior model interface. Right, I said right. So what it is, there will be a can signal will be there. So those things we can manage signal path. Okay, so vehicle speed is there. So vehicle speed from where to where, source and destination, where to where it has to transmit. So those things we can manage the signal path completely, right? Between the external device and behavior model interface. So behavior model is nothing but plant model. Okay, so external devices in the sense ECU, right? So those things we can manage here and automatically implement behavior model code and IO function code. Okay, so behavior model is plant model. So it will be the model can be run by the this configuration disk and also the IO function code. IO function in the sense input output. Okay, it comes under all the digital, analog, and protocols, right? So this is about the configuration disk. So what it will do usually configuration disk configure. So, okay, so it will configure the complete input outputs. Okay, it will manage signal paths. Okay, and next how it look like configuration disk. Okay, so these are the, so if you see there is a functionalities lock and unlock. Okay, so these are the left door control, right door control. Okay, so likewise function for particular ECU, whatever the functionality we are going to test, those we can map. So here what it is going, so signal, so there will be a lock signal is there, unlock signal is there. So those things we can map it. Okay, so and also the ground. Okay, whatever the ECU is having the inputs and outputs, right? So those things we can map here, right? So it's like a model based configuration environment. Okay, so we have all the if you see left side, so these are the APIs I told, right? Function libraries and everything. So there will be a current in, voltage in, so everything, pulse pattern. I mean, IOs will be there, digital IO, and CAN related. Those things will be there, and for each input, each electrical interfaces. Okay, so we'll be having the some properties. So how much, what is the channel we have to use, and here you can see assign the channel set. So this we already discussed, right? IO module, there will be a cards will be there inside the hardware, right? So those for which board we need to map and for which channel we need to use, and then how much rating, current rating it has. So those things we can do that. And next to failure simulation, can you see failure simulation here? So those things we can configure also here. Open circuit allowed, short to ground allowed. Okay, short to signal generator not allowed, not allowed. Based upon our requirement, we can configure. Clear? Next. So this is about the configuration disk. Okay. So next, control disk. Okay. So control disk, what it will have? Control disk experiment is a collection of project related files to control the real time applications. Right. So collection of project related files means, so there will be like a test cases or anything models or anything or any specific files. So those things one can control over in this software. So it is a graphical test sequence generator. It features a project manager that simplifies organization, management, execution of large testing projects. The graphical organized structure representation of test elements, test platforms, test data, reports. Okay, so the test elements reduces the test management time and maintenance effort, thereby reducing the cost. So in configuration disk, what we'll do, we'll configure only, right? But where we'll run the test cases, the test management, where it will be happen. Okay, so here in control disk, so it will be like a test management, right? We can execute large testing projects. So whether it could be, I mean, depends on the template, whether it is a Excel sheet, I mean, whatever the test sequence will be there, right? So those things we can generate. Test sequence can be generated on this. Like each test case is having the some scenario, right? So those things we can generate here in the control desk. Okay, so it is an excellent tool for team that develops test software because it is minimalizes the cumbersome task of writing, managing, and bring commonality to the test script. So what you understood? So if you want to write a test cases, so there will be a, like a, we need to write some number of hundreds of 200 300 test cases we need to write, right, for a particular functionality. Okay, so here we can create the test sequence. That sequence we can use it for the multiple test cases. How we can, so for example, there will be a precondition is there. Okay, so preconditions and the test steps will be there. So those are for few number of test cases. Those are common for those kind of test cases. Clear? So that is a one particular scenario. So that we can create in control desk and we can execute the test cases, right? So depends on our requirement, because it will be cumbersome task writing and managing the bring commonly to the test scripts. Okay, so test scripts use the, it will call these functions, it will call this test sequence, and it will execute test script. Understood? Okay, so that is what control desk to do. And graphical test sequence programming. Okay, test sequence programming. And next, project manager for large test projects, data and results. And extendable automation libraries will have. Okay, automation libraries in the sense it can be like for CAN libraries, LIN libraries, or IO libraries. So how it has to send the data and receive the data. So those things, and scripting via Python script. So those things also we can do. And result navigator for viewing the test results, automated XML based report generation. So report also we can generate, right? Once we done the test, so what we can do? We can generate the report in the format, which format it is, HTML or PDF format. Okay, depends on our requirement. We can generate the report in this control desk, and it's a open architecture to interface with the third party tools via COM and DLLs. Okay, DLL, you know. So DLL usually, yeah. So DLL usually what diagnostic security access will use, right? So like kind of there will be some DLL or COM related tools. I mean third party tools will be there. Those also we can interface. Okay, for example, if you want to use the Canoe, okay, so Canoe also Canoe through the COM, so we can integrate third party tools, Canoe or MATLAB or anything, we can integrate to this tool, right? And next, ability to create a Word or Excel document dynamically as test runs. Okay, so ability to create a Word or an Excel document dynamically as a test runs. Test is running. Okay, so we need a logs. Okay, but we are getting the report. We can generate the report, but we need a whatever the logs, right? Whatever the communication happenings and everything, so that we can get it in Excel sheet or Word during the test run. And next, remote control of control desk. So remotely we can control the control desk. Okay, so for example, I mean some other country it has, so we'll be getting the access, control desk access. It's not about the team viewer or anything. Okay, so we'll get the access through the control desk only from our laptop or PC. Okay, so access Simulink models and environment through scripting. Okay, so Simulink models, what we discussed, plant models, right? There will be like environment through. So and accessing the Simulink models we can access, and then environment through the scripting. What is environment? Okay, so there are like a CAN bus signals, or else I mean PWM, ADC, DAC. So all those signals, digital IOs. So all those are the environment, ECU environment, right? ECU inputs and outputs. So those things we can access through script, right? We can access the plant model, we can access the all the digital IOs and analog IOs, everything, right, through this control desk. So this control desk, how it will be communicate to Simulink model and this environment through the configuration desk. Okay, so through the configuration desk, it will communicate with those things. Okay, so usually how it look like control desk. So there will be a project manager here. So it's a complete one project. For example, airbag or ADAS or anything. So will be having, we have to create the project here itself in control desk only. We can create the project particularly. Okay, so if we want to execute a run the hill test for different ECUs, so then what we'll do, we'll load the configuration here. I mean the project, we'll open the project and we'll run the project. Okay, likewise here only we can completely execute the complete hill automate. I mean execute the testing. Okay, we'll load the project and we'll execute. We'll run the project and it will get communicated with the EC. Okay, so this is what it is: test sequence, controller, and editor. So it will be look like. Okay, so what we can see, we already discussed, right? So it will be a configure control desk is a sequence generator, test sequence generator. So we can generate the sequence, right? And next there will be a like library, and next there will be a, like a data object browser. So library is for if it is for the CAN or a LIN or any communication protocol related, those things we can see here. And data object browser, those things also we can see here. And log results window, so here we can see the execution. So what happening, whether it is, I mean, communicating with the hardware or not, whether it is in the sending the CAN signal or not, so everything you can see it over here. Okay, so usually one more advantage what we have seen in the initial description, control desk. So we can, it's a graphical user interface, right? So we can access all the signals, right? So here what we can see, it's a like if you see in Canoi there is a control panel, right, where we can access all the inputs, outputs, and like the switches and gauges, everything we can configure. Okay, so here battery voltage also we can set. Okay, and also the throttle power on, pressure sensor, so the status, it will get updated. Okay, real time. So whatever the ECU output will give, right, signals, those things will be get updated here. Okay, and here you can see, so here are some rotary switches there. So graphical one, so air filter, differential pressure, so those things, and key switches, coolant temperature, intake manifold. So these will get inputs and outputs, we can modify, we can control, and we can see the output of the signal. Okay, so this is like a dashboard. So control desk is having the this dashboard, which will be having the graphical user interface to control and monitor inputs and outputs. Clear? So this is about the control disk. Okay, so this is a where we can do the manual testing also. One thing. Okay, if you want to do the manual testing, where we can do, in control disk. Okay, by accessing the all the inputs and outputs over on the dashboard. Next, another tool, what it is, automation disk. Right? What is automation disk? So there is a configuration disk which we can configure, and another control disk is there which we can control inputs, outputs, and automation disk in the sense we can do the automation. Usually, what it will do, test authoring and automation tool. Right? With automation disk, what will do? Test can be executed 24 hours day, right? 7 days a week, 24 by 7. We can execute the test cases by using automation disk. Continuously, we can execute. and letting engineers increase test coverage and improve ECU software quality while saving time and cost. So that is the main benefit of dspace, right? So continuously, what we have discussed yesterday, night run. Okay, night run in the sense it will be a 24 by 7 execution of test cases. So usually automation desk is having a core enables test execution on Linux PC or Linux Dockers. It can be on Windows also. Okay. So again, what it will be having graphical description of test routines, right? So there will be a test routines will be there, right? So how we have to test. So what are the functions, libraries? For example, if you want to ignition on, do the ignition on. So what are the libraries we have to use? So those are the like a test routines. So we can graphically graphical description of a test routines will be there. And next, advanced custom library concept. Okay, so custom library in the sense, so we can create our own libraries or existing libraries also we can use. Okay, so for example, if we have a new protocol, okay, some IPR sent protocol, any sensor related protocol, those things we can write on our own libraries and we can incorporate into this. Okay, automation desk. And next, remote control of calibration, measurement, and diagnostic tools such as control disk. Okay, so what we can do? Remote control. So with the automation disk also we can do the remote control. Okay, calibration, calibration, measurement, and diagnostic tools, Okay, so OBD, UDS, okay, diagnostics, right? So those things will be calibration measurement in the sense. So we can do the, for example, if it is a motor is there, right? So motor, how much speed it is rotating. Okay, so we can calibrate those things. For the sensors also we can calibrate. So how much distance it has to sense. Okay, and within how much for if it is a radar is there, right? So radar will be having the some range will be there, maximum range. But for us, how much range we need to detect? Okay, within how much range we need to detect, that comes under the calibration and measurement. Okay, that we can do in this by using a automation desk. Okay, automation desk is a powerful test authoring and automation tool for hardware in loop hill testing electronic control unit ECUs, right? So automation desk users can create and edit test routines in a graphical format without requiring programming skills. We don't need programming skills. Okay, what we need only test routines. Oh, which will be like a using the libraries. Okay, so if we want to execute one particular functionality, ignition on, or else power moding, or else some particular scenarios. So those things we can create and we can execute. No need of programming skills. And next, automation desk interface libraries. As it's right, so there will be a custom libraries we can use. So for any particular protocol we can write, or any particular communication, data interpretation, so everything, and compliant with the SM standards. So SM is actually the automotive standard, so which will be having some database standards, right? So database in the sense communication protocol, how it has to be communication happens, and how the interpretation happens. So that is as per the SM, okay, automotive standard, allows for a seamless reuse of automated test cases across different development stages. Okay, if you have created for one particular project, all these libraries that can be used for another project also. Okay, if it is a similar kind of scenarios. Okay, and automation desk provides the libraries containing a large number of predefined test steps. Okay, for easy access to simulation model and a failure insertion model unit. Okay, or a calibration or diagnostic software. Okay, so it it has a inbuilt libraries, okay, to access the simulation model in the sense plant model under the FIU and diagnostic, okay, UDS diagnostic center. And with automation desk, test can be executed 24 hours a day, right? 7 days, and letting industry increase test coverage, improves the ECU software quality, right? Clear? What is the use of automation desk? Simply It is a graphical to develop the test routines, okay, using the graphical interface. Okay, so without using the any programming skills, right? So we can create the all the libraries, so which will be useful for the test execution. Okay, so these are the main thing. And what we can do, it has a inbuilt libraries also. Okay, for what? Simulation models or plant models, and also the failure insertion FIU, and also the UDS diagnostics. Okay, inbuilt libraries will be there. And as well, we can create the some test routines also as per our requirement. Clear? And next, so this is how it looks, the automation desk. Okay, so here we can see what we have seen: throttle, right? So in before slide we have seen, right, throttle. So that graphical representation is there, so how it is, the value is changing from one cycle to another cycle, right? So and we have some API convenience, all the libraries will be there, right? Read, write, read values, write values, okay, capture the, so get capture all the whatever the conditions will be there, right? Signal conditioning and everything. So those things we can access here. And so here we can see graphical, this is one routine actually. Okay, graphically we can create one test routines, that is a use, right? Okay, so what we can do here, for example, conditioning. Okay, conditioning extended value. So configure the start condition, right? Start condition in the sense ignition on, engine speed, so those things, preconditions. So those things we can configure here. Okay, this is like a one test routine to run one test case. Okay, and next to left side, what we can see, so custom design. So it can be depends on the, so in strings, integer, float, so data types, all the data types, and also the like sequence also we can create. Okay, so then triggered capture. Okay, so what are the battery voltage value, okay, front light. Oh, these are the routines, right? So routines we can create it in automation desk, all the routines, right? Then next, so quick start. So how we can so we till now what we know, so what are the dspace consist, hardware parts, and also the software tools what we require, okay, that we have. And next, how we have to start using these tools. Okay, so first, switch on the power supply. Okay, so we have the battery, I mean power supply, right, for the hill automation. Then switch off the power supply. Then so the supply of the real-time hardware. Okay, black rocker switch, that is a PX20 we call it as in the hardware. Okay, so the for the of the real-time hardware, and it turns on the internal power supply for the signal conditioning cards and the dspace cards. Okay, so there is a signal conditioning and the processor and everything, right? So it will give the power supply switch, it will gives the power to all the signal conditioning and all the cards, right? And next, output voltage will be zero until the voltage applied in the control desk main layout. Okay, so output voltage, why it will be zero? Because there is a programmable power supply, right? So programmable power supply will gives the input power to the ECU. Okay, so by this is the power supply in the switch on power supply in the dspace dspace rack. Okay, so there will be a programmable power supply, so which will give the all the inputs and outputs to the ECU. And to start the control desk, first what we have to do, so we have to configure the all the environment, plant models and the DBC and whatever required for that using the configuration disk. Okay, then comes to the control desk. So control desk, what we can do, we can create the projects for different issues, for airbag or ADAS or BCM or anything. Okay, then next simply double click on the main experiment. Okay, so this is the extension, file extension. What is this? cdx dot cdx is the file extension. Okay, so to perform the following steps, how we can do in control days, we'll load the project, okay, which is based upon .cdx format file, and then next open control disk from the Windows Start menu, and in control disk select the file, open experiment, select the file in the sense select a .cdx file and open experiment. Okay, the experiment for the simulator can be found in which, so this location, this is a standard location, so where we can find the this experiment, okay, to test the airbag or any ECU. And next control list, now refresh the platform connection. Okay, what it will do, so it will, there is a refresh button is there. Okay, if you click on that, so what it will do, it will refresh all the connections. Okay, so what are the connections? There will be like to the ECU, there will be like a analog CAN and digital IOs and everything, right? So those things will be refreshed. There, those things will be connected to the power supplies and everything, connected to the power supply, goes to the signal, goes to the ECU. Okay, so refresh button in control desk, and next opens the experiment and downloads the software to the real-time hardware. Okay, so what is the software? So software in the sense, what we have plant model is there, right? So opens the experiment and downloads the software to the real-time hardware. So here real-time hardware in the sense it's a simulator. Okay, so in the simulator what will load? Plant model. Yesterday we discussed, right, plant model. So particular to simulate the all the inputs and outputs, plant model will be used. So that will be loaded into the real-time hardware, which is nothing but simulator processor. Okay, so that who will load? Control desk. And if you switch to the animation mode, the simulator is ready to use. Okay, so there will be a animation modes which will be there. So if you click on that, so it will be run continuously, then we can do our own testing. So control desk, what we can do, we can access all the inputs outputs. Dashboard is there, right? All the controls, switches and everything, GUI switches, so everything we can access all the data to and fro from the ECU. Okay, so this is how it looks like. So host PC, we have a host PC where we have all the softwares required, dspace softwares, and here input file in the sense test cases. So we load the test cases, okay, and it will run the test case here in the control desk, and whether automation desk also. It will be passed through the dspace hardware and then goes to the actual hardware load. These are the loads. Load box is there, right? Load box we have seen, right, all the motors and lights and everything. So these are the load, hardware load, and this is the ECU. Okay, so the communication happens between, so how, this is a host pieces to hardware and hardware to ECU. Okay, from hardware we'll get the some information also. Okay, feedback, power supply feedbacks and everything, so we'll get the from ECU. And next hardware load, it's a whether it is running or not. So steering. So what are the sensors? If we rotate the steering, so how it will be rotating? What is the angle and everything? Like whether it is, will be having the lights and everything. So whether it is get on or not. So by using the load box, we can connect all these things. And result file. So what we have seen, result file will be in the format of XML or Excel or anything. PDF and everything. So by using the configuration desk, sorry, control desk, we can generate the report test results. Okay, so this is how it will be seen. And next, possible ECU testing. So what will have possible? So we can do the functional testing, diagnostic testing, self healing, voltage profiling, and win means vehicle integration, and EOL means end of line testing, network management, HMI testing, signal gateway testing. So there are different types of testings. All the testings we can do it in dspace. Okay, so till now what we understood, hardware software tools of dspace, right? So we'll see some sample test cases, okay, of this auto high beam hill system. Okay, sample test cases, we can see how we can write the test cases mainly. So automatic high beam, what is this automatic high beam? Automatic high beam system depends on the forward looking camera mounted in the rear view mirror. On rear view mirror, there will be a camera. If you see in Audi car and BWM car, there will be a rear view camera in the sorry, in the rear view mirror. Sorry, camera will be mounted on that, and that camera detects the various forms of lights, including headlights and tail lights and ambient light from the cities. Okay, and next the system then crunches the information to determine when to have the high beams on. Okay, so if you travel in the city, right? So if you travel in the city, there will be headlights will be there. I mean, street lights will be there. Okay, so depends on the ambient light intensity. Okay, so that camera will detect and it will activate the high beam or low beam. Okay, so that is the application of ADAS application. Okay, so this is a simple, I mean, description of the project. So for this, how we can write the test cases? Here you can see. Is it visible?
No, sir.
No,
Okay.
sir.
So what we can do, we can maximize here. I think if I maximize it is going blur, right? Okay, I will explain. So usually there will be a test scenario. We all know, right? Usually manual testing or anything, we can have the test scenario. Test scenario is what it is. Test scenario identification, AHB override. What is this test scenario? So it evaluates that override logic works correctly and the system can be always override by customer in the sense passenger driver. Okay, so driver, so while he's sitting the, I mean, he switches on the high beam, right? So what happens, so manually if he switches on the high beam, okay, this system what it will do, AHB high beam, it will overrides, so it will override, it will whether it could be off or on, it will override that functionality high beam, right? So that is a scenario, and this is a test case identification and test definition. Vehicle is equipped with the front camera, and next vehicle is configured for the AHB, and next no relevant DTCs are set. Okay, so this is the system configuration, and next initial conditions. Okay, initial conditions, what are they? Auto high beam checkbox activated in the menu, and next master light switch is auto position ignition of darkness in the and around the vehicle. Okay, so darkness in the sense, so if it has to be a high beam should be on, right? So it should be a daytime. It is not required, right? High beam is not required, so it won't on. So we should make sure that it should be a darkness around the vehicle. So ignition should be off. Okay, so these are the initial conditions, like preconditions. So empty straight road. So straight road will be without light sources. Okay, then next, what it will do, test action, start engine. Okay, then expected result. What we have expected result, AHB telltale on, it will override, right? So AHB high beam will get on. I mean telltale will be get on, and high beam off. High beam telltale off. Okay, so there will be a, this is different. High beam is different. High beam telltale is different. There is a AHP telltale automated, right? So this is the automated functionality. So these are the high beam is a manual functionality. Okay, if the driver switch on the high beam manually, then this will be get on. Okay, and this telltale will be get on for manual function. Okay, here what it is overriding AHB, automated high beam is overriding on manual, right? So then expected result should be this telltale should be on and this should be off. Okay, so that is the expected result. So for this in hill dspace, how we can write activate the all the signals. Okay, so test implementation for the automated execution. How we can do system configuration? Okay, set test simulation initial conditions of ASB we can do. Right. Already we have seen right system configuration in previous columns. So here what we are doing, there is no script actually. So directly in the test only, test cases only what we are doing, we are directly calling this library. So this is a test routine. Okay, we have seen right in control desk. So we can create the test routines right in automation desk and control desk also we can create the some test routines, right? So here in automation desk we have created this test routine. So here we are triggering this calling this test routine. Okay, what is a test routine system configuration? Then next, initial conditions. Okay, so initial conditions, what are they? So set ignition. Okay, then wait and set auto high beam feature in. Okay, then wait and set lean communication. So everything, whatever the initial condition, preconditions will be there, that we are calling the, these are the test routines, right? In the automation desk. And next, test action. What we have to do? Test action. So here everything will be there here only. Okay, whatever we here we are written the description, right? Those we are doing it there in the test routine. We are calling those functions. And here test action, what we are doing? Start engine, right? So here set maneuver. Okay, maneuver trigger long crank. Okay, we are starting the engine here. Test action. So expected result is, so dipped high beam. Okay, check dipped. So whether it is a high beam is on or not. Okay, go on. We are expecting the result this. Okay, check high beam lamp off. Okay, so this is a manual high beam lamp, so that's why it has to be off. So we are giving the status also. First one is a automated high beam, that should be on. And next, check classic high beam indicator status off. Okay, check auto high beam indicator status on. Okay, so these are the expected result what we are expecting from this test case. Likewise we'll write the test case. Okay, so these are the test routines we can call it as. This will be what we'll do, this test case will upload into the automation desk, and from the automation desk we can execute all the test cases one by one. Clear? So this is about how we are going to write the test case. Okay. So with this we completed the session. Okay. So any doubts? So I will share the this PPT and both the PPTs. So which we discussed yesterday and today. This one dspace. Okay. Clear? So this is how we can execute the test cases. Okay, we can map it anything, any project we can map it based upon this test cases template. Clear?
When
Okay.
canoe will be used, sir?
Canoe will be used only for the manual testing. Okay, so if you want to see the
Now,
any can signals, then only. So or else we can see the all the can signals. I told right, control desk. So control desk we
okay.
can all we can see, we can keep a can signal, particular can signal, and we can see the its a value over here in control desk. So there is no use of canoe. So if you want to use additionally, we can connect it through BOB. That is our
Okay.
optional. I mean,
If
no.
we are using hill system, then no need of using canoe. Yeah, means running of CAPL programs and all.
Capel program why we'll run? We already having the this test script, right? Test cases we
Yes.
already having. So why will use Capel scripting? No need to
Okay.
use
No
of,
need.
yeah.
Then in some cases we will be using Python programs and all.
Yeah,
That
so yeah, usually see, so these are the test routines I said, right? So these
yes.
test routines we can create in a Python script where in automation desk.
Okay.
But here to write the test cases, no need of any Python script.
Okay. No Python or no Capel.
No Capel and no Python. Just we'll get to know about the routines, test routines, and those things will sequence wise we need to write.
These are executed in Hill system.
Yeah, hill system.
Okay. dspace is a
Okay.
part of Hill system, and there are various types of hills like ETAs and all.
Yes, there are different types of hill automation system. Okay, clear? Okay, then yeah.
Mm.
So we are closing
Sir,
the
if
session.
Right.
interviewer asks what are the challenges? Hello?
Challenges. See,
You
if
faced
you
in
are,
this space.
yeah. So dspace there are many challenges. See from scratch. So if you want to commissioning complete, setuping complete environment. So that is the thing. And so whatever the tools we discussed, right? Configuration desk. We need to make sure configuration desk has to be do complete configuration. And next control desk is there. The it is also required some setup, project setup, and automation desk, the test routines where we can develop. So those things, so these are the complete challenges only, I mean, where we can, these are run back end, but front end what we'll do, only we'll write the test cases. What your job? So writing the test cases here.
Okay.
That's it. So as per the requirement.
Okay.
That's
Wait,
it.
wait. Hello, Sri. Hello.
Yeah, hello.
Interviewer asked which type of code you are using,
Sorry.
which type of cards you are using, and interviewer asking that like that.
I told, right, cards, these are the cards. This is the processor board card and multi-channel, and these are the cards, board wiring and Hill digital IO cards. Okay, so I already told, right?
Oh,
Hello, sir.
yeah.
Hmm.
Hello, sir. In hill setting, which processor we are using? Microcontroller, microprocessor, anything?
This is what here processor board is there, right? In this processor will be there.
Okay, sir.
Okay, so this is the board. I mean, the card
PS1.
number. Okay,
Okay.
yeah.
Sir, we are using in PC model. Which models are అంటే different types of PC లో మనకి ఈ అంటే సాఫ్ట్వేర్ వెర్షన్ అంటే ఏం చెప్పాలి సార్? యాక్చువల్గా పీసీలో మనం డిస్పేస్ కి సాఫ్ట్వేర్ వెర్షన్ ఉంటుంది.
Yes, sir. PC host software, like how it looks.
PC host అంటే see, so usually ఏంటి విండోస్ యూజ్ చేస్తాం మనం, ఓకేనా? సో బేస్డ్ అపాన్ దట్ కాన్ఫిగరేషన్ డెస్క్ జనరల్గా ఏంటి లేటెస్ట్ వర్షన్ వచ్చేసి ఏదైతే ఉందో అది మీరు చెప్పేయచ్చు. కాన్ఫిగరేషన్
Yes,
డెస్క్
sir.
కానీ లేకపోతే కంట్రోల్ డెస్క్ కానీ లేటెస్ట్ వర్షన్ అది మీరు చెప్పేయచ్చు వర్షన్. సో అండ్ సో సి అంత డీప్గా ఏంటంటే సి ఫర్ ఎగ్జాంపుల్ మీరు సింపుల్గా ఏం చెప్పచ్చు. సో వీఆర్ యూజింగ్ ద ఓన్లీ రిమోట్ యాక్సెస్. We don't have the complete access to the hardware or the softwares. So usually any companies, if you go any company, they won't give any direct access to you, okay, to the hill, because it's very costly and it's a very complicated. So they don't want to even touch the system also. But where we can write the test cases, we can upload the test cases into the automation desk. That we can do. That's it. And that too, see, this system, hill system can be used by multiple test engineers, right? So due to that, it can be placed in, I mean, offshore offices or the on-site. So mostly it can be accessed through the remote only. Okay, what we can say? So we can have the access to the control desk and automation desk. So where we can control desk, we can see all the outputs and inputs, and automation desk where we can upload the all the test cases. That's it.
Yeah, Suresh, can you please tell tools version, control desk and all?
Tools version, those things we can set it in, right? So, for example, go to dspace site and set it
Okay.
to what are the function latest dspace will be there. So, go to dspace hill, and there you can find all the related information.
Sure. Thanks.
Okay.
Hi, sir.
Sir, sir,
Yeah, yeah, yeah,
One more doubt, sir. How to
yeah.
set up the dspace?
Set up the dspace in the sense.
అంటే హోస్ట్ పీసీ నుంచి మనం కనెక్ట్ చేసుకోవడం
Huh?
మన సెటప్ సార్ dspace సెటప్
dspace
He's
setup. See,
asking
there are
about the bench setup, hill setup, hill bench
see
setup.
what we discussed today. That is a complete whatever the content it consists. Okay, so hill setup consists of everything. So these wirings and between all these things and everything communication related. So this comes under the setup only. And whatever the communication happens right from host to this, that is also setup comes under the setup. And this IO boards mapping read, so that is also comes under the setup only. Okay, so everything, so BOB box and power supply, and next hardware software tools. So this is also comes under the setup only. How we can do the configuration desk, control desk, automation desk, and plant model. So this comes under the complete setup. So what we go through is a whatever it is, that is a complete comes under the setup only.
వన్ మోర్ క్వశ్చన్ సార్
Hmm.
హౌ మెనీ panels boards are used in dspace?
Sorry,
How many panels boards are used in dspace? Panel boards.
what is a panel board?
This is called okay, interview question, sir.
Huh?
Interview question.
See, that's what I'm saying, right? So there will be a like boards. So there will be a hardware process boards will be there. Okay, so though these are the boards, you can answer it to that.
Okay, panel boards, right?
Panel board in the sense, see panel board in the sense, see if you see here, so these are comes under into the panel only. This is the panel.
Okay.
So there are the partitions will be there. Okay, this is the processor, signal conditioning, load, BOB, and everything. This thing, right?
in the
This you
panel
can.
there will be partitions.
Yeah, yes, different devices will be there, right?
How to set the
Sir,
threshold position, sir?
Huh?
How to set the threshold position?
Threshold. What is that threshold?
Sorry, throttle position.
Throttle position.
Yes.
Throttle position. See, that is as per the requirement, as per the specification. If you have that is depends on the project which you kept, right? So if you have the throttle input, so how you are setting up? So because throttle is having the usually in vehicle, so there will be a throttle input, right? It will be having the sensor. So based upon the sensor, EC will detect and it will give the output. That's it.
sir, I have a doubt regarding interview question.
Hmm.
For us, in our class, they said about airbag through hill system. He said that to
తెలుగులో
assume
చెప్పండి తెలుగులో చెప్పండి.
loop cards, బకల్ సెన్సార్ కార్డ్స్ ఇలా ఉంటాయి, బ్యాటరీ కార్డ్, క్యాన్ కార్డ్ ఇవన్నీ ఉంటాయని మాకు ఎయిర్ బ్యాగ్ ఎక్స్ప్లెయిన్ చేశారనమాట త్రూ హిల్ సిస్టమ్. కనెక్షన్స్, ఈసీయూ, క్యాన్ కేస్ ఎక్సెల్ ఇలా చెప్పారనమాట. నాకు ఇంటర్వ్యూలో ఏం అడిగారంటే ఎక్స్ప్లెయిన్ రాడార్ యూజింగ్ హిల్ సిస్టమ్ అని అన్నారు.
ఏం చేయాలి అని అంటే మీకు అందులో ప్రాజెక్ట్ లో ఇచ్చిన ఇన్పుట్స్ అవుట్పుట్స్ ఉన్నాయి కదా, సో దాన్ని ఈ టెస్ట్ కేస్ లో మ్యాప్ చేసుకోవాలి మనం.
ఓకే, మీరు ఇప్పుడు చెప్పిన ఐఓ బోర్డ్స్ ఇవన్నీ ఉంటాయి హిల్ సిస్టమ్ లో అని చెప్పి
అని చెప్పి
ఇన్పుట్స్ మేము సిమ్యులేట్
టెస్ట్ కేసు
చేసాము అని చెప్పాను.
టెస్ట్ కేసు ఎలా రాస్తామంటే ఈ ఫార్మాట్ లో రాస్తాము టెంప్లెట్ లో అని చెప్పాలి.
ఓకే, అంటే మీరు ఏమన్నా చెప్పగలుగుతారా, అంటే ఇప్పుడు ఇన్పుట్స్ ఏవేవి
అది ఆ
ఇస్తాము?
ప్రాజెక్ట్ నాకు తెలియదు అది.
ఓకే, అంటే మాకేం చెప్పారంటే డిటెక్షన్ చేస్తుంది రాడార్ అని చెప్పారు. అవే కదా ఇన్పుట్స్ ఇంకా.
అదే దానికి అదే చెప్తున్నాను. ఇప్పుడు ఆ ప్రాజెక్ట్‌లో మీకు ఇన్‌పుట్స్, అవుట్‌పుట్స్ ఏవైతే ఉన్నాయో, సో, దాన్ని ఈ టెస్ట్ కేస్ దిస్ ఈస్ ఎ వన్ టెస్ట్ కేస్ రైట్? అందులో గూడా మీకు టెస్ట్ కేస్ ఇచ్చుంటారు రాడార్‌కి. సో, ఆ టెస్ట్ కేస్‌ని దీనికి మ్యాప్ చేసుకొని చెప్పాలి.
ఓకే. ఇన్పుట్స్ వచ్చేసి డిటెక్షన్స్ అని చెప్పారు. ప్లస్ ఆ ఇన్పుట్స్ తీసుకొని ఏఎస్డిఎం
ఏదైనా,
మాడ్యూల్.
ఏదైనా మీరేదైనా తీసుకోండి. ఇన్‌పుట్ ఏదైనా తీసుకున్నా గానీ అది దీనికి మ్యాప్ చేసుకోవాలి. ఇందులో గూడా ఉన్నాయి గదా!
ఆ!
ఇన్‌పుట్ సిస్టమ్
అవును.
కాన్ఫిగరేషన్,
అంటే
ఇనిషియల్,
ఇప్పుడు
టెస్ట్ యాక్షన్.
అవుట్పుట్ అవుట్పుట్స్ ఎక్కడ మెన్షన్ చేయాలి? అంటే రాడార్ నుంచి ఇన్పుట్ ఏఎస్డిఎం తీసుకొని
ఎక్స్‌పెక్టెడ్
ఏఎస్డిఎం
అవుట్‌పుట్ ఉంది
నుంచి
గదా! ఎక్స్‌పెక్టెడ్ రిజల్ట్‌లో అవుట్‌పుట్ మెన్షన్ చేస్తాం మనం. దిస్ ఈస్ ఎ సింపుల్ టెస్ట్ కేస్ టెంప్లేట్. ఓకే.
సార్ హలో సార్,
యాహ్!
మనం
ఓకే.
రాడార్లో హిల్ సెటప్ అనేది యూజ్ చేయాలి సార్.
ఆ!
రాడార్లో హిల్ సెటప్ అనేది యూజ్ చేయలేము సార్.
రాడార్‌లో హిల్ సెటప్ గాదు. హిల్ సెటప్‌లో రాడార్ యూజ్ చేస్తాం. హిల్ సెటప్‌లో
ఆ!
రాడార్‌లో హిల్ సెటప్ ఏంటి?
లేదు సార్, రైజర్ ప్రాజెక్ట్ తీసుకొని హిల్ సెటప్ యూజ్ చేయలేము సార్.
ఆ!
ఇప్పుడు ఎయిర్ బ్యాగ్ ప్రాజెక్ట్ యూజ్ చేసుకొని హిల్ సెటప్ యూజ్ చేస్తాం కదా సార్.
ఓకే.
సేమ్ అలాగే రాడార్ తీసుకొని హిల్ సెటప్ లో యూజ్ చేయలేం, మనం వర్క్ చేయలేము అక్కడ.
చెయ్యలేము అంటున్నారా? చెయ్యొచ్చు.
అవును సార్.
దేనికైనా ఏ ప్రాజెక్ట్‌కైనా చెయ్యొచ్చు గదా! చెప్పాను గదా ఆల్రెడీ. ఓకేనా? సో, దట్స్ ఇట్ అవర్ సెషన్ అండ్ ఓకే.
సార్
సార్ ఆ,
ఈసీయూకి మెయిన్ పిన్స్ జనరల్ గా ఎనీ ప్రాజెక్ట్ లో ఆ పిన్స్ ఏవేవి అలా ఎక్స్ప్లెయిన్ చేయగలుగుతారా?
ఈసీయూ పిన్స్ మీ ప్రాజెక్ట్ ఏదైతే పెట్టుకున్నారో దాన్ని బట్టి ఉంటుంది. ఈసీ పిన్స్ ఏవైతే ఉంటాయో దాన్ని మనం హిల్ సిస్టమ్‌కి కాన్ఫిగర్ చేసుకోవాలి. అంతే.
మైక్రో
అంటే
కంట్రోలర్
పిన్ పొజిషన్
8051
పిన్
పిన్
పొజిషన్
పొజిషన్ అదే ప్రాజెక్ట్‌ని బట్టి ఉంటది అది.
సార్,
అంటే
మైక్రో కంట్రోలర్
మాకు
తీసుకుంటారు కదా సార్, అది
చెప్తారా?
మైక్రో కంట్రోలర్.
మాకు తెలీదు. మీ ప్రాజెక్ట్ ఏంటనేది నాకు తెలీదు కాబట్టి నేను చెప్పలేను దానికి.
సార్, మైక్రో
ఓకేనా?
కంట్రోల్ మీన్స్
బేస్డ్ అపాన్ ద ప్రాజెక్ట్.
LP2148 ఆర్మ్ కార్టెక్స్ అలాంటి మైక్రో కంట్రోల్ తీసుకుంటే సరిపోతుంది సార్.
ఆ!
మైక్రో కంట్రోలర్స్ యాక్చువల్ గా పిన్ డయాగ్రమ్ గురించి ఎక్స్ప్లెయిన్ చేయమంటే 8051 మైక్రో కంట్రోలర్ కానీ లేదంటే LP214 ఆర్మ్ కార్టెక్స్ కానీ మైక్రో కంట్రోలర్స్ ఉంటాయి కదా సార్, వాటివి
అంటే
పిన్స్.
మైక్రో కంట్రోలర్ గురించి అడిగితే అది ఎక్స్‌ప్లెయిన్ చేయొచ్చు. మీకు ఏ దాని గురించి అడిగితే అది ఎక్స్‌ప్లెయిన్ చేయొచ్చు. అంతే. ప్రాజెక్ట్ గురించి అడిగితే ప్రాజెక్ట్ గురించి ఎక్స్‌ప్లెయిన్ చేయాలి. ఇన్‌పుట్, అవుట్‌పుట్స్ అంతే. ఓకేనా? ఓకే దెన్ థాంక్స్ గైస్. థాంక్స్ ఫర్ అటెండింగ్ ద సెషన్. యాహ్! బై. థాంక్ యూ.
sir, can you share PPTs in the group?
యాహ్! షూర్.
థ్యాంక్ యూ.
డెఫినెట్‌లీ.